Hello, and welcome to Theme Thursday here on Answer Everywhere. The theme for the past couple of weeks has been Haskell build systems, Haskell packaging systems, things in the Haskell environment that are related to building, packaging up your software, distributing your software, stuff like that. Last week, we took a look at the Hadrian build system, which is a build system customized to the GHC Haskell compiler that's used for building the compiler. And today we're looking at Cabal, which is a tool for packaging up and distributing your Haskell thingies, binaries, packages, libraries, that sort of thing. And I believe it's part of GHC, but I'm not 100% positive. So we'll check that out. I added a schedule on YouTube. Here's just what it looks like. For Monday, Monday, we're going to look more at the gRPC ecosystem, specifically at the Python bindings. Let me minimize this so maybe this is easier to see. And the goal there is to get a sense of when you want to implement a gRPC language implementation that's calling out to the core C++/C gRPC functions, how does that look? And Python happens to be one of the languages where they're just calling out to C with a foreign function interface. So I wanted to take a look at what that looks like. On Tools Tuesday, we're going to be looking at Bash. I actually got a request yesterday for, among other things, a shell. I don't remember offhand if it was Bash specifically. I think it was just a Unix shell. Yeah. So on Network Wednesday, we're going to take a look at Linux sockets. We kind of saw some sockets in use when we were looking at TCP. And then I saw that the sockets file itself was gigantic. So I'll take a closer look at that file and kind of see how other pieces of code in the Linux networking code base repository use those sockets. On Theme Thursday, we're continuing with the Haskell build environment theme, and we'll look at Stack, which is built on top of Cabal, and is my understanding anyway, is it's essentially a nice UI layer that makes it easier to work with Haskell code. And then on Fun Friday, I'm going to look at an open source game called Super Tux Kart. I was originally thinking I would look at, I think Tux Racer it was called, but Tux Racer seems to maybe no longer be developed, and Super Tux Kart seems to be under active development. Also on Friday, I'm planning to do something I haven't done before, which is I'm going to do a collaboration with my brother where we're going to be playing a video game. And that game is called Disco Elysium. And I'm not sure whether I'm going to stream that to YouTube or whether we're going to do it to Twitch. So if anyone has a preference, a strong preference or a weak preference, let me know. But it's a little bit different from the rest of the content that's on this channel. And it's not an open source game. So I want to make sure that however I do it, I kind of flag that it's a different sort of thing. And the idea there is that my brother and I, grew up playing games. He continued to actively play games, and I sort of haven't done it since I was a little kid. But we've been toying around with the idea of making a game together. And I've been kind of interested in, what I've been missing. So this is a game that he thinks that I would really enjoy. And so we're going to just kind of play through that and try to have some fun. And so that'll also be on Friday in the afternoon. I don't think we have a specific time yet, but if you're interested, that will either be here or on Twitch, and I'll put a schedule up wherever it is. And if it's not on, if I end up doing it on Twitch, I'll put some sort of pointer up on YouTube so you can find it more easily. So that's administrative stuff. I think that's all the administrative stuff I had. Oh yeah, no, I was gonna say I've gotten a ton of requests, like really great requests for really great videos, and my list of video ideas that I have is really long. So I just wanted to say first of all, thank you for all of the requests. I feel like people really are understanding are understanding what I'm up to, and and like so far everyone's been asking for stuff that's like really in line with what I've been thinking, and so I appreciate that. But naturally, the more requests I get, the longer the backlog will be. So and I'm not necessarily going to do them on a first in first out basis because I want to try to have a certain momentum or a certain feel to how we're doing things. So, for example, I want to make sure it either aligns with the theme days, or there's a way to create a whole theme week around a common theme that's actually coherent. So please do make requests if there's something you want to see, but but it may not I may not get to everything immediately, I guess is what I'm trying to say. So so that's great. And again, thank you everyone. All right. So here is the disconnected. Hang on. I'm being told that OBS is disconnecting. I think I'm connected again. Let me see if I can pull up my own stream. Okay. Yeah, it seems to think I'm live on YouTube. All right. Can't tell because it's on a delay. All right. So I'll assume I'm still live. Okay. So here's Cabal. I am on their GitHub. Haskell, I think, also has a GitLab. I don't really remember where it is, but GitHub seems good enough for our purposes. There are a couple of things in the README that caught my eye. One is that I can chat via Matrix, which is like a distributed, I think it's distributed chat thingy. I don't know what Libera is. That might be like, what's it called? IRC? Let's find out what this is. It's an IRC network. Okay. So you can chat with them via IRC or Matrix. That's nice to see because a lot of open source folks have their chats on something like Discord, which Discord is nice, but it's also nice to be able to chat with open source people without having like a Discord login or whatever. And there's some stuff about installing, and I also thought this was they give us a link to Cabal-syntax, which is going to be the .cabal file format library. And there are different licenses. I guess just out of curiosity, let's see if these are the same license. We have a copyright statement. I don't know offhand what this license is. Isaac Jones. Okay. These seem to be identical licenses. I'm sure GitHub will tell us which license it is. And so I'm just curious where here's Cabal-syntax. So we may want to look at that. And I guess if we're going to look at Cabal syntax, we should maybe look at least one Cabal file. Let's see if the Cabal project itself has its own file, its own Cabal file. Maybe Cabal.project. And again, maybe before we get too deep in here, I should give the usual proviso that I'm not a Haskell developer. This is me learning the Haskell ecosystem kind of in a strange way. This is not the way I would ordinarily learn the ecosystem. But I think it's an interesting way. I think the idea of kind of exploring code like this is interesting. So if you're coming here as a veteran Haskell developer, and I don't understand some basic stuff, that's just kind of by design of how I'm going about this. Okay, so I'm not sure if this is the Cabal format. For sure, we'll be able to find. Let's see if I'll just search for .cabal. What's a popular Haskell library? How about Haskell? I think conduit, maybe. I think this is a thing I've heard of. So this I vaguely recall being a relatively complicated library. We've got a stack.yaml. I was hoping for a .cabal file. Maybe I can just find some online. Package description. We've got, okay, I think this is supposed to be one. This looks like the right kind of format. So it's got name, version, library. Library does not have a colon. And we've got build depends, exposed modules. So I guess the build depends on this dependency base, and base has to be bigger than or equal to 4, and double and, I guess base is less than 5. And this is a, I don't know, I guess you would call it a constraint. Okay, so we're going to have constraints. I'm not sure if this is YAML. This is certainly YAML-like. Extensions, I'm not sure what extensions will be. The Cabal file will say what modules are exposed. And then I guess this is conditional. If the OS is Windows, is how I assume this is supposed to be read, then again, no colon or braces or anything like that. We have an additional build depends. So, and here's an example from HUnit. Name, blah, 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 metadata, all of this stuff. And then library, and then under the library, there's a stanza that again has things like build depends, exposed modules. So we're going to see how they define this syntax. And then we'll also presumably see something that's going to read this file and build up some sort of description of how things should be compiled based on this file. And so, for example, whatever that code is, it should look at things like build depends, but also, check these conditionals and then possibly add additional dependencies to the thing it had up here. So just some things that we can look out for as we're looking through the code. And then with that in mind, let's take another look at the cabal.project file. Here we get packages, and constraints. I don't know. Let's look up .project. So the Cabal.project file support a variety of options which configure the details of your build. I keep disconnecting. So I'm not sure what's going on with my internet right now. I suspect that maybe there's some ISP stuff, although it doesn't seem very stormy or whatever. But at any rate, the recording will continue, and I'll upload the recording even if I get disconnected. So there's a Cabal.project, and then somehow there's like a .cabal file, and the Cabal project file seems to configure details of the build. The general syntax is similar to that of a Cabal file. There are a number of fields, some of which are some of which live inside stanzas. Groups of fields that apply to only one part of the project. Okay, so this is maybe at a higher level of abstraction, or it configures the whole, I guess, project. And the .cabal files are more local. I'm not sure. We'll see. Maybe .cabal files are inside of directories. I don't know. Okay, so back to GitHub. We'll get out of this project file. Let's move syntax to its own window. And let's look at Cabal. I guess I'm going to ignore Bootstrap. I'll look at Cabal tests. Cabal described, I'm not sure. I'll look at Cabal quick check. Cabal install test suite changelog. Editor is Vim. So maybe the Cabal authors are Vim users. Release notes, solver benchmarks. And by editors Vim, I think GitHub is telling me that the only thing in editors is the Vim directory. I think that's what GitHub means in GitHub. And then there's some template stuff, which maybe I want to look at, I guess. And then there's a stack file. I don't know if the Cabal project uses stack itself or if this is just to support other packages using stack. We have validate.sh, and I'll look at it. And I have no idea what dhall is, but let's check it out. And you know what? Actually, I do want to look at solver benchmarks. And I don't think I opened templates, but I am going to open templates. All right, we'll take a quick look at templates just because it's right here. And these are Haskell files. We've got elixir.x. I don't know what the .x extension is, but presumably some Lexer builder. Paths, package template, license exception ID template, license ID template, Cabal macros. I guess I'll just quickly look at these just to see what they're supposed to be doing. Here's a Lexer for Cabal files. And language CPP, this looks like Haskell to me. Language bang patterns, these are like configuring, I think GHC options. And this is configuring the variable options GHC. I forget what these are called, but these are like optional functionality that your compiler can support that has a name that's slipping my mind right now. All right, so so we've just got this Lexer module, and it's got, I don't know why it has a .x file. I guess something's maybe going to pre-process it. We manually produce the lexer.hs file from boot/lexer.x, make lexer, because bootstrapping Cabal install would otherwise be tricky. Alex is at the moment tricky package to build. Cabal install has some magic to move bundled generated files in place. So rather, we don't depend on it before we can build it ourselves. Therefore, there's one less thing to worry about in bootstrap.sh, which is a win. All right, some sort of making sure some stuff happens before other stuff needs to happen. And so here's the Lexer. I guess we don't get beautiful syntax highlighting as much because of the .x extension, or maybe we do. We get some. And it looks like defining up a grammar. Think the space, I guess, looks like this. I don't know why it's a slash. Control characters, symbols, field braces are like escape. Parentheses are escaped, either round brackets or square brackets. Where was space tab is, I guess, a space followed by a tab. A comment is something printable followed by a tab. That doesn't sound right. Or maybe it is. Maybe that's what a comment is in this file. Okay, so what else do we got? Bowl section. Don't know what bowl is supposed to be. And here I don't recognize this syntax. This might be part of the generating stuff. Okay, so we have infield layout. Yeah, I'm wondering if this, Let's look up Lexer .x extension. Alex, okay. Lexing with Alex. So I guess Alex seems to be some sort of lexing tool for the Haskell world. This is part of a Parsing with Haskell series. Alex and Happy. I feel like I've seen Happy, but I don't know what it is. Both Alex and Happy are industrial strength tools, powerful enough to parse even Haskell itself. But I don't know if that's surprising. Is Haskell supposed to be hard to parse? Okay, so these are like lexing tools. And this is presumably some sort of Alex format. Okay. Looks good. Here's the Cabal macros template.h. And .h maybe means it's going to be a C++ header. And we've got if and defs defined, blah, blah, blah. Whether we're going to mangle the package name, I don't know. It always makes me smile to think of, I think mangle was well named. Whoever decided to call it mangling. All right, so this is some macros, I guess C macros or C++ macros that are for some reason in a template, which maybe implies that it's going to be generated. Okay, do not edit. This file is automatically generated by Cabal. Okay, so I guess Cabal generates this file and they commit it to version control. And we've got things like tool version, minimum tool version, current component ID, etc. Okay. We have spdx license ID template.hs. And this is a Haskell file and not a C header. And we're going to explore things like license is FS Libra, FSF Libra, license is OSI approved, make license ID list, license ID migration message. So let's try to think about what it's going to do. Presumably, I don't think it has a way of computing from the license text whether something is, let's say, FSF, Libra, or OSI approved. Presumably, it somehow got a list of approved or Libra licenses, and it's going to just match whatever license we have with that. Maybe it will peek inside of the licenses and look for keywords that are common. Maybe it has like a hash of what the standard license files look like. That's probably the way to do it, assuming that if you could take the standard file and add copyright info, then the hash trick won't work. But if the licenses are always the same, then it will work. Otherwise, it might do something like just look at the name of the file. So we'll see what it does. And okay, we've got instance binary license ID, where put is equal to binary. We're going to set put to be equal to binary.putword 16BE, presumably a 16-bit word, but BE, I don't know what that means. From integral, I guess, from enum. So we're going to convert an enum to an integer, and I guess consider it to be a word and write that as put. Word 16 is encoded in big endianness. Okay, so it's big endian, I think is what it means. And this is just all, so we're just taking a license ID, instance binary, which is an instance of binary. Okay. License ID is an instance of structured. It's an instance of pretty, which I guess means that we can pretty print it. So I guess in Haskell world, this is saying like, here's the implement. Not only is it an instance of binary, let's say, look at this line, but here's specifically how you convert it to binary. You call this function. And similarly, here is how you pretty princess. Here's how you pretty print the license ID. You're going to set pretty to be display text composed with license ID. Display.text, rather. Okay. We've got this parsec, I guess, support, NF data, license ID migration message. Oh, maybe maybe instead of like looking at the license, we're just telling people that they have to declare what kind of license it is. And then this is going to be maybe read from the Cabal file or the project file. Help message for migrating from SPDX license identifiers. Okay, okay, I should have remembered this, but SPDX is some sort of license stuff. Let's actually look this up once and for all. Software Package Data Exchange. It's an open standard for software bill of materials. SPDX allows the expression of components, licenses, copyrights, and security references, and other metadata relating to software. All right. Syntax, that's not so important for us, but maybe I'm wondering if we can find a list of like fields. Do they have a website? Why do I feel like I'm in the mobile version? No? Fair enough. Is there a specification? Yeah. But it's going to be slow for whatever reason. Okay. Downloaded in OWL format. I just wanted a specification, but it's giving me an ontology. That's kind of wild. I don't have a way of browsing this as an ontology, but that's pretty cool. Is there like elements? Here's a license list. It's a lot of license, many of which I'm not sure I've heard of. What else do we have? SPDX Lite. File information, package information, document conformance, terms and definitions, normative references and scope. Seems pretty thorough. Okay. Something SPDX related, and here's an RDF, I guess, tuple. Cool. All right. That was a bit of a rabbit hole. Was that a rabbit hole? I don't think that was a rabbit hole, but it was a side mission, a distraction, I guess, from our primary goal. Okay, so we're just going to read the license ID, and that's that. Okay, so that's not actually doing any super interesting work. It's more like massaging data provided to it. And then here's, I guess, going to be similar. I don't know why these are templates. And I don't know like what is instantiating the template. I guess here, oh, you know what? Maybe is this template Haskell? How would I know? I think template Haskell people abbreviate as TH. Okay, match case. And I think you would have a language pragma or whatever these are called for template Haskell. So maybe they're not. Let's look up template Haskell. Tips and tricks. An example to select an element from a tuple of arbitrary size. Use like so. So we're going to have this cell23 thing, and it's got a $sign in front of it. And we're going to, I guess, apply it to A, B, C as strings. And it's going to return B. And if we call cell34 A, B, C, D, it's going to give us C. Extract an element from a tuple of arbitrary size. I guess this means select 2 from 3. And this means select 3 from 4. And cell is is this the generated? I don't know. This is int to int to exp_q, whatever exp_q is. And we've got this $sign here. And maybe that's the template-y part. That's got case E and alt. Yeah, I don't know. Okay. So maybe it is template Haskell. I don't know if we're if template Haskell requires you to. Okay. Yeah. So language template Haskell, language template Haskell. So I guess it's probably not template Haskell because we're not using whatever this thing is called, unless there's something that says to always use template Haskell regardless of what's in the file, which there might be, but we're not going to dwell on it. Okay, so here we are in Cabal/Cabal. This is the main package, and we've got miscellaneous and source/distribution. Miscellaneous, I'm going to guess I can mostly ignore. Generate authors and Travis diff files. I think Travis might be a is that a CI thing? I vaguely recalled something called Travis, but I forget what it is. Okay, so here we are in Cabal/source/distribution. We've got backpack, compat, package description, simple, types, utils, verbosity, get opt, lex, make, read e.hs, simple.hs, test suite verbosity, and Zinza prelude. All right, here's Cabal's tests. So I guess let's just take a quick look at tests. We've got parser tests, no thunks, unit tests, RPM, version comparison maybe, miscellaneous, hackage, custom setup, cbits, unit tests, test. A lot of tests. That's good. Since this is such a fundamental part of Haskell, it's nice to see that it seems to be thoroughly tested. We've got some quick check stuff, a Cabal file. Yeah, maybe Cabal is like supposed to be per directory. So let's look at Cabal. And we've got a version, name, synopsis, category, description, this library thing, GHC options, that depends. And I guess the style is to comma separate them, but the comma goes after the new line and is on the left, and the modules that are exposed. Cool. All right, so here's, let's look at Vim. And FT plugin, not sure what FT is, but some sort of Vim plugin. And some syntax, I guess maybe syntax highlighting. Here's .vim. I guess this is some Vim language that looks maybe a little bit bash-y, maybe like a shell script a little bit. But it's got let bindings. And whatever a syn is, synonym maybe? Okay. So Vim stuff. Here's stack.yaml. And it's going to basically do a similar thing, I guess, to the Cabal file, but in stack land. And it's got some Nix stuff. And there's some, like, I think Nix has some stuff for converting Cabal files to Nix files and stuff like that. There's a the Haskell people seem to be super into Nix, if I understand correctly. Okay, so validate.sh. I'm just curious what's being validated here. And okay, so we're defining a bunch of environment variables. Here's a function that's going to, I guess, create this file, which looks like a help message. So yeah, okay, show usage. That makes sense. Set the output file to some temporary file that's I guess returned by make temp. These are colors, I guess, for coloring the output. And we're going to time some stuff and do stuff with the colors. All right. We can parse options. This is some get opt thing. I guess we're parsing options for the validator script. And what are the options? Extra HC with Cabal plan with Cabal with compiler, run the CLI suite, run lib suite, run CLI tests. Okay. So this seems mildly interesting. If steps, then steps is equal to pretty print tool versions, and steps is equal to this previous thing plus build. And if doc test, so if I guess we requested doc test probably, then we're going to append doc test to the steps. So we've got steps, and it's kind of like a vector, but really it's a string of steps, and the steps are separated by white space, by a single space. Okay. And then targets, we've got some like pre-baked targets like Cabal, Cabal Test Suite, etc. And depending on the, I guess, arguments you passed in, there might be additional targets. Like Cabal install is not a default, is not there by default. If you ask for lib only, you do not get Cabal install. You only get this stuff on this line. And if you ask it to list the steps, it'll print them. Okay. We're going to assume the compiler is GHC and set run Haskell to echo HC, I think, which was GHC. And we're going to call sed, which we did a video on sed, I think on Tuesday, and you should check it out. And sed is going to execute this substitution. We're going to substitute GHC, whatever version is, with run GHC. I am not sure entirely what run GHC does, but maybe that's a nicer interface to GHC somehow. Look at the OS type, check whether we're asking to build the libraries only. And I think ultimately we're just going to call GHC on the targets. And that's going to be how we test stuff. And so here's some stuff for step build, step doc tests, step lib tests. Okay. Well, let's look at the test suite. Step CLI tests. Yeah, look at that. All right, so it's going to, I guess we're going to print out that we're doing some Cabal install tests. These are assorted in ascending time used quicker tests first. Okay. So we're going to set command to be Cabal plan list bin of, so we're going to list the long tests and whatever test suite jobs is and hide successes. Then we're going to cd into Cabal install and run the command timed and exit. Okay. All right. Seems like a pretty good bash script or shell script. Let's see if it specifies exactly which shell. SH. I'm not sure if SH. Just out of curiosity, let's see what SH is on my machine, on this Geeks machine. Okay. So it just says, and it's going to symlink. It's on different lines, but it's got bash. It's got bash here. So I think that SH is bash. Although it changes my prompt. I think I'm in bash. So maybe it's bash with different different environmental variables or something. Well, can I find out what is that a thing? Yeah, and then if I do sh, can I do shell? These seem to be the same. And I'm just for fun, I'm gonna output the yeah, okay. So sh is bash here. On some systems I've used, there is no bash. There's only sh. I don't know if anyone uses the original shell that bash is the born again version of, but there are various other shells. I think that some are limited in size or in ability so that you can fit them into like tiny containers and stuff. Okay, so weeder.dh haul or dhall just has this thing, roots, main security. I don't know. Add more weeder roots. Let's see if dhall is a thing we should know about. The dhall configuration language, doll. Okay, I thought it might be doll, but I wasn't sure. Doll is a programmable configuration language you can think of as JSON plus functions plus types plus imports. Isn't that JavaScript? Isn't that JavaScript? JavaScript has functions and types and imports and the JavaScript object notation. Okay, a programmable configuration language. All right, so some sort of Turing complete I guess is probably what it means by programmable config language. Okay. So let's look at the meat. Now that we're 40 minutes. Oh, and there's also solver benchmarks. I guess let's move solver benchmarks to its own thing and then get to the meat of Cabal. Okay, so let's see. Verbosity, utils, type, simple. Let's look at the Haskell files before we look at the directories, because often that'll just be enough, I think, to figure out what's going on. So Zinza prelude, a small prelude used in Zinza generated template modules. I'm wondering if Zinza is like a play on Jinja. I don't know. Okay, so the modules we're going to export is writer, exec writer, tell, 4m, which is like I guess a monadic for each type thing, generic, package name, version, and pretty show. And there's not much here. So for example, instance monad writer is return equals pure. M, I forget how you pronounce this. The monads have like bind and I forget what the other one is called. I think this might be bind. And we're going to set k equal to 1. And we have this lambda. S1 is going to go to some unw stuff and more unw stuff. Do we have unw defined? We have w. And unw is show s. It's going to take a show s and return a show s a. So it's going to essentially wrap it in a tuple. Where does the a come from? Okay, writer a. All right. Okay. Instance functor writer. So to get a functor, I guess we call lift m. Applicative writer. I'm not really sure what this thing is because I don't know the applicative library. Okay, and tell is going to take a string and return a writer of empty string. And tell of s, tell applied to s is going to give us w, which is the, I guess, kind of, I'm not sure what it's called, but it's essentially like a new writer, a writer constructor of the lambda. S prime is going to go to s prime dot show string s and then the empty string. I have no idea what this is doing or what Zinza is. Let's look up Zinza. Zinza people, Zinza technology. How about Zinza Haskell? It is related to Jinja. Zinza is a small Jinja syntax inspired typed template compiler. Zinza type checks and compiles the template. We can compile either to Haskell to a Haskell function or to verbatim Haskell module. For example, given a template like this and data definitions like this. So so this template says like for license and licenses, we're going to print some stuff. So when this expands, I assume in Jinja and also Zinza that this will have like one license name per licenses, which is some sort of container of licenses, most likely some sort of list. And to get this to expand properly, we have to define some types. Like we need to tell it what to do with licenses. And licenses is a list of license. And a license is a thing that has a license con and a license name. And we have some other boilerplate stuff. And then we see how to use it. And I don't know if it shows us what the generated, what the expanded template looks like. But that's Zinza. It's some sort of template expander in a similar vein to Jinja. All right, here's verbosity.hs. Maybe this is just for configuring verbosity. There are 4 standard verbosity levels from silent, normal, verbose, up to deafening. This is used for deciding what logging messages to print. Okay, so this is logging stuff. I guess there's not really a reason to look super closely at this, but we will peek through it. See things like call site, call stack, no wrap, so token. So somehow we're going to tokenize stuff, and the tokens can have different, I was going to say types, but these are just strings. Yeah. Return verbose call site. Let's look at what verbose call site does, just to look at one of these implementations. Okay, so turn on verbose call site printing when we log, because verbose call site is going to take a verbosity and return a verbosity. And it's just defined to be verbose flag v call site. Of whatever is passed in, I guess. Let's see how this is used again, which is how we originally started. Well, here's a bool that's going to tell us whether something is a verbose call site. And that's going to be defined as is verbose flag v call site. Okay. All right. Okay. We can show level silent, that sort of stuff. Cool. All right, here's test suite. Let's ignore test suite because we've already spent a lot of time looking at other stuff, I guess. All right, here's simple.hs. This is the command line front end to the simple build system. When given a parsed command line args, the parsed command line args and package information is able to perform basic commands like configure, build, install, register, etc. This module exports the main functions that setup.hs scripts use. It re-exports the user hooks type. This module isn't called simple because it's simple. Far from it. It's called simple because it does complicated things to simple software. The original idea was that there could be different build systems that all presented the same compatible command line interface. This is still a distribution.make system, but in practice, no packages use it. Or there is still, okay. Let's look up Haskell simple. Industrial Haskell users are realizing that the key to delivering software on time and under budget is to keep it simple. Okay, they've got a philosophy, but what is it? I'm not sure. Some sort of build system. Haskell simple input and output. Oh, I mean, I think this is not related to the simple thing. Okay, whatever simple is, it's this thing. I'm not sure if this is fundamental, so I'm going to skip it. And then if everything calls simple repeatedly, I guess I'll come back. All right, here's read E. Simple parsing with failure. I guess read with error. Here's make.hs. This is an alternative build system that delegates everything to the make program. All the commands just end up calling make with appropriate arguments. The intention was to allow pre-existing packages that used make files to be wrapped into Cabal packages. In practice, essentially all such packages were converted over to the simple build system instead. Okay, so maybe simple is fundamental. Consequently, this module is not much used and certainly only sees cursory maintenance and no testing. Perhaps at some point we should stop pretending that it works. At least that's an honest comment. That's nice to see. Okay, so this file is going to do something probably similar in spirit to what Hadrian was up to. It's going to build Haskell projects using make. And they're telling us that it's basically in maintenance mode and that I should look at simple instead, which I will do. So here's lex.hs. We're going to presumably lex some stuff. Tokenize quoted words. Why quoted? I don't know. We're going to filter some stuff. Go bool in quoted region. I guess whether this bool will tell us whether we're quoted. There's an accumulator of characters, I guess. A string to be parsed in a parse result, which is in the parse result is just a list of strings. All right, so that's relatively simple. We're going to call go. So if we call go with no bool and an accumulator and the empty list as a string, I think 1, 2, 3, 1, 2, 3, yeah. Then, if the last argument, I guess, is empty. We're just going to keep it empty. Otherwise, we're just going to put the accumulator prime in the list, where accumulator prime is going to be called, we're going to call a run D list on the accumulator. And I'm not sure where run D list is, but it's presumably defined somewhere. All right. So that's relatively simple. Get opt is probably almost certainly just option parsing. Yeah, usage info, get opt. This is the same as get opt, but returns a quadruple consisting of the option arguments, a list of non-options, a list of unrecognized options, and a list of error messages. We can handle long options. Okay, options parsing. All right, so that leaves really simple.hs and implementations and the syntax. But just for thoroughness, I'll take a quick look at backpack and compat. Compat has snock list, stack, time, get short path name, file path, create, pipe, async, prelude, and internal. I don't know what snock list is. A very reversed list has efficient snock. I guess it's the opposite of cons. Why is this compat though? Let's look at process. And it's got system process stuff, create process, enable process jobs. Oh, okay. So this has got a bunch of Windows stuff in it. So maybe by compat, they mean like stuff that's specific to different OS environments like Windows versus Unix or Mac or whatever. All right, backpack. We've got module shape, mix link, linked component, full unit ID, describe unit ID, configured component, configure components graph. I'll look at components graph, unify M, ready component. I don't know what backpack is doing. Here we go. GHC proposals backpack. Will GitHub let me click on this link? I don't know. Well, Firefox. Can I open as a link? Open link. There we go. Oh, but all right. So backpack. There's a nice drawing of a backpack here, which you would see if I didn't have my dark CSS thing on. All right. So good backpack. All right, so introduction, motivation, etc. So it's a proposal to add mix-in libraries to Haskell. Mix-in libraries can have signatures, which permit implementations of values and types to be deferred, while allowing a library with missing implementations to still be type checked. So here's the motivation. Suppose you are writing a string processing library, which in principle could operate on byte string, text, and string equally well. Ideally, you would be able to write a library to support all three types, while at the same time achieving the following properties. You don't want to copy and paste, it's just normal Haskell, no performance overhead, egalitarian interfaces. I guess you want to declare the abstract interface without having to rely on some central authority, having to define what it means to be something string-like. Interface composability, extensibility, package level modularity, separate type checking. It should be possible, by which it means it should be possible to type check a parameterized package without committing to any particular implementation. Backpack seeks to solve all these problems where existing language features in Haskell are not up to the task. Dictionary passing is one option that doesn't seem to work. Okay, so I'll look at this later, but something about mixins, support for mixins. So do we care about mixins? Maybe. Let's look at a couple of mixins. So where am I? Backpack. Okay. I think I opened some mixins, or what I assume are mixins. We have a unification monad, which has unify, run, unify with, fail with, add error. Some module U. These are modules and unit IDs. Module subst U and whatnot. To do more detailed trace output with high verbosity would probably be appreciated by users debugging unification errors. Collect some good examples. So we've got error message. We have run unify, which will run a computation in the unification monad. And it has a verbosity, a component ID, and a full DB. We've got this for all thing. And you're going to get either a message doc or A. And I'm not sure what A is, but whatever the A here from the unify thingy is. And I guess I'm not going to really try to read this because I don't know enough about what's going on. I forget how the for all is handled. And I don't really know. I assume maybe kind of like type unification. But we've got an H map and a CID and verbosity and doing stuff with the database. Okay. It seems a bit complicated. We've got applicative monad, some commented out code. Okay. Maybe that's not commented out code. I think I just closed it, but okay. Where are we now? Oh, this is unify. So the thing that I said was commented out code actually has a brace in front of it, and it's not this double. It's not the double dash, which is the Haskell comment thing. So I'm not sure what this is. Maybe I don't know if it's another Haskell comment style, but it's the same thing. And maybe it's like a preprocessor thing. It's the same curly brace dash delimited thing as like the language pragmas. All right, where am I? Ready component. This will maybe be more understandable to me than the unify stuff. A ready component is one that we can actually generate build products for. We have a ready component for the type check only products of every indefinite package, as well as a ready component for every way these packages can be fully instantiated. So I guess a ready component is one we can actually generate build products for. So it's ready in some sense. I guess some pre-processing has been done. And I'm guessing that maybe the mix-in stuff happens because it somehow applies to all sorts of components and is not like typed to one kind of component. Perhaps? I don't know. Okay, let's just move along. So types. Thank you. Addy, is that how I pronounce it? Addy. Just said that they just saw my channel and this is amazing. I really appreciate that. Thanks. So types, I don't know what's in types, but we can dump build info, given component.hs, local build info, target info. Let's look at target info, annotate DID or DLD. It's hard to tell with the font, but let's take a look at what it does. So here's target info.hs, and we've got a graph, so that's good. Seems like we're getting to the more buildy parts of the software. So the target info contains all the information necessary to build a specific target, for example, component/module/file in a package. In principle, one can get the component from the component local build info and local build info, but it is much more convenient to have the component in hand. So I guess we're going to wrap whatever component local build info is as a target info object, essentially. I don't think you call it an object in the Haskell world, but maybe like a record. And then we've got just the target CLBI is the component local build info, and the target component is the component. So we're just wrapping together the metadata with the thing, it seems like maybe. And we can check whether it's a node. All right. Instance is node target info where type key target info equals unit ID. So I guess that has to be true. And node key, and it, I guess is node needs to have two like methods maybe, and one is node key, and we get that by calling node. We just kind of pass through the node key call to the target CLBI, and similarly with node neighbors. So it's the local build info, I guess it has the graphy stuff, and this is just kind of like a convenience wrapper that has the graphy stuff with essentially like a pointer to the actual component or something like that. So where's the local build info? It's in types. Okay. So let's look at that somewhere. And before we do that, we opened up, okay, annotate ID. Annotated ID. Okay, I thought it was annotate DID, but annotated ID, I guess makes more sense. An annotated ID is a component ID, unit ID, etc., which is annotated with some other useful information that is useful for printing to users, etc. Okay, so I think we've seen this pattern in other source code repositories. Not positive that this is what's going on, but morally speaking, there's a lot of software, a lot of the complicated software in the world, like compilers, build systems, presumably schedulers. One of the things they do is they build typically a directed acyclic graph, something you can topologically sort. Or, and in general, it's probably more general than that, but you have some graph, right? You have nodes that are connected in some configuration, and you want to do things like call a function once per node, which I think is just essentially the visitor pattern. Or you want to annotate a node, so you want to add metadata to it in some way. And I think that annotate ID is basically functionality to annotate the graph in some useful way. So let's just do a sanity check and see if that seems right. So invariant, if an ID of x is equal to an ID of y, then an PID of x is equal to an PID of y, and an CNAME of x is equal to an CNAME of y. Okay, so if they have the same, if they have the same ID, if they have the same ID, the same annotated ID, which I'll just call ID in this context, then they have the same package ID, and their CNAMEs are the same. And a CNAME is a component name. So the same package ID and the same component name. They may not have the same version, I guess. I don't know if the component name considers version. But it's the same, I guess, component. And so we can order them, we can compare them. And then this other stuff seems to just, again, we're just like instance package, the package ID, we're just going to pass through it to the an ID. And there's not much there. There might be more in a folder called annotated ID. But no, okay, magic. I should know magic. Magic package names. Is this just like magic numbers? It's a placeholder and distribution.backpack.ready component. Non-existence package. This is a Cabal bug. Okay, so this is just setting like a failure string as a default, I guess. So if you see it, something went wrong. Fake package name, fake package Cabal file name. Okay, that's what magic is doing. Here's component local build info. Just curious whether this is long, not super long. All right. Now the first 5 fields are common across all algebraic variants. Cool. And what are we exporting? Some stuff, component-y stuff. What are we importing? We've got backpack, graph. Graph is compat. And I think we decided that compat was basically platform dependent code. So somehow graph is going to depend on the platform. That's not shocking. If you want your graph to be performance optimized, often performance optimizing might be different by platform. I'm not sure. Maybe we will look at that. Maybe we won't. We'll see how it goes. We've got some component ID, unit ID, component name, munged package name, and module renaming. Okay, and then the local build info has a name, an ID, unit ID, whether it's indefinite. An indefinite component has unfilled holes. All right. How it was instantiated, what its dependencies are, resolved internal and external package dependencies for this component. The build info specifies a set of build dependencies that must be satisfied. Okay. And includes exe deps. What is that? Is that like runtime dependencies? Set of packages that are brought into scope during compilation, including module renaming. Yeah, I don't know. Okay. Internal dependencies, which induce a graph on the component local build info of this package. This does not coincide with component package deps because it also records build tool dependencies on executables. So I think this is similar to something we saw maybe in Bazel, where you've got your real dependencies, which I think is component package deps. And then you also have to build things. So you need to know maybe where like GHC is, or like you need the linker itself might be a dependency, those sorts of things. And so you need to have a way of adding them essentially to the dependencies. And they do the, I think Bazel did it by just appending it to the dependencies. And it seems like they, Haskell or Cabal is doing it by having a separate field with the internal dependencies. And presumably somewhere in the code, they're going to throw both the internal dependencies and the package dependencies in the same list or something. And then the compiler will see them as one big bag of stuff. We want to refactor all the duplicates as a to-do. But we've got this flib component local build info stuff, exe component local build info. I don't know what these are. This seems to be an or sign. So I guess this is kind of like a union. It can either be one of these. It can either be this thing or that thing, I think is what the syntax means. And it's going to derive some stuff like generic read, show, and typable. And we've got isNode. And isNode has, okay, so key of component local build info is unit ID. Okay, and node key is going to be component unit ID, and node neighbors is going to be component internal deps. The node neighbors are the internal deps. So maybe internal deps includes the other, includes the package deps. So maybe package deps is not only the, maybe internal deps is maybe not just the separate deps from package deps. Maybe it's the whole thing. And then package deps is essentially internal deps set minus the like hidden internal dependency somehow, I guess. And we've got maybe component instantiated with and some stuff. Okay, so this is essentially the graph node stuff, if I'm understanding correctly. It's got a bunch of stuff, but if you squint your eyes, it's an adjacency list, I guess, with this thing is defining a node, and then internal deps is a list of unit IDs. And this thing should be identifiable by a single unit ID, and that makes component internal deps essentially an adjacency list of nodes. And that's basically what it says. Internal dependencies induces a graph on the component local build info of this package. Okay. Cool. And here's simple. Let's look at simple, finally. And then I think I still have one window open, which, I think I still have one window open, which is the syntax of the Cabal file. I'll look through that quickly. We saw already some stuff about lexing and parsing. We didn't really look through it, but we kind of glanced at it. And since we've done some compiler stuff before, we'll just assume it's similar to lexing and parsing other things. But it's nice to at least look at it and see if there's any surprises or if they have any super cool tricks that we haven't seen before. All right, so here we are in simple.hs. So it seems like this is the thing that's going to do a bunch of work. We'll see. So it's the, we looked at this comment before. It's the command line front end to this simple build system. When given the parsed command line args and package information, maybe, I don't know if that means the whole package graph, it's able to perform basic commands like configure, build, install, register, etc. I don't know what register is, but I know configure, build, and install are all standard things. It's ultimately going to call GHC, right? And so what do we expect it to do? We expect it to take all the graph stuff, maybe figure out the order that things need to be built in, and then pass that into GHC. And then I don't know if, yeah, I don't know how much information you can feed GHC and expect it to just keep churning. You might have to build one package at a time, or you might be able to pass in like an entire plan to GHC and have it like build all the sub packages and figure stuff out for you. So we'll see how it goes. Okay, so distribution.simple, we've got package. These are the exports: package, version, license, compiler. I think there's a simple directory, right? Let's at least open this simple directory. Yeah, look at that. Okay. We'll look at compiler and command and configure and build target. Test setup program. Preprocess installers. What's program? Built-in run response file LD script strip types. R is presumably archive. LD is presumably linker. HPC, that could be high performance computing, but I'm going to guess it's not. Look at types. And DB, which I think is going to be a database of package info. So here, let's go back to simple now that we've opened up some other files. And let's see how big simple is. It looks pretty big, much larger than any file we've looked at so far in this code base. Okay, so about 700 lines, 690 to be exact. Let's read from the bottom. Sometimes that's good. We've got a default register hook, I guess. So we're going to register stuff, install hook. So what do the hooks do? They're going to take a package description, local build info, user hooks, and install flags, and do an IO operation. Cool. And they're hooks. So I guess you get to customize them like hooks somehow. All right. So test hooks get hooked build info. All right. Add autoconf user hooks. Basic autoconf user hooks. Postconf runs configure if present. Pre-hooks, pre-build, pre-clean, pre-copy, pre-instant, blah, blah, blah. Read additional build information. Okay. So let's see. Pre-clean is going to be a read hook that takes in clean verbosity, which is maybe a configurable way to set for like a set verbosity for the clean command, I guess, and a clean dist pref, which I suppose is some sort of preference. And it's just going to do this sort of stuff. And yeah, okay. Simple user hooks, package this clean. Yeah, all right. Cleaning takes a package description and some clean flags and does an IO operation. And given package desker and flags, we're going to do, we're going to get the dist preference somehow. We're going to call notice. I guess notice is like emit a notice given the verbosity, and maybe conditionally depending on whether it's suitable for the verbosity. This is cleaning. We're going to try to get a config from clean save conf. Maybe get persist build configure. Okay. And then remove the whole dist directory rather than tracking exactly what files we created there. So we're going to remove the directory. We've got chatty try, which presumably is like a try fail thing that is somewhat verbose, or at least can optionally be verbose. And we're going to traverse underscore any extra files that the user wants to remove. We're going to have this traverse thing. We're going to call remove file or directory to the extra temp files in the package description. Okay. So traverse seems like it would be a graph sort of function. It might be. I vaguely recall hearing about traverse. It might be somewhat related to applicative. Let's look it up before I say something totally incorrect. Yeah, it is traverse underscore. It's the same as fmap, except that it also allows you to run effects while you're rebuilding the data structure. Okay, so it's got some functors of tree. A traversable instance is almost the same, except the constructors are called in applicative style. It's some traversy applicative thing. And yeah, okay. So the sort of thing it's going to do is remove the file or directory given this information. And I guess the kind of like link structure, the thing that we're traversing is probably in extra temp files. All right. Read the, okay, so we can get build config, try get build config. Sanity check hooked build info. All right. Okay, here we go. Register action. So register action is going to take a collection of user hooks, plural user hooks, some flags, register flags, and arguments. And it's going to do, it's called for its side effect. It's going to do an empty IO operation. And what is that operation? Hooked action. Verbosity, pre-reg, reg hook, post reg, get build, config, hooks, verbosity, disprev, hooks, flags, args. The last thing it's doing is calling hooked action. And what is pre-reg? Let's find out what pre-reg is. Can I highlight them without getting lost? Maybe not. Reg hook, post reg. Okay, so let's maybe look closer. So we're going to get the find dist pref or default, set the verbosity, get build config hooks verbosity dist pref, let flags be equal to this stuff. Yeah, I don't know where pre-reg comes from, or reg hook, or post reg. And what is reg hook? Is reg hook, that's not the thing we passed in, right? And hooks, flags, reg args equals args. So presumably it's registering some stuff. And we've got pre-reg and post-reg. I don't know if those are actions to happen before registration and after registration, or if they are the thing registered before it and the thing registered after it. I'm not sure. Here's hooked action. It's going to take a verbosity, some user hooks. Oh, no, this is a whole thing. A function, it's going to take a function that takes user hooks and args and flags and gives you an IO hooked build info. It's going to take a function that takes user hooks, package description, local build info, more user hooks, flags, and does an IO thing. All right, let's look at what they, okay. So some functions that act on user hooks somehow. And it's going to give you, and it's going to take an IO local build info. And it's going to return ultimately it's going to return like I guess some function that does IO. And maybe the thing it returns based on just the formatting is going to be a function that takes user hooks and flags and args and actually applies to the hook, presumably. So hooked action, so here's the definition. The hooked action is you're verbosity, prehook, command hook. Okay. So that's consuming 3 arguments. This is the verbosity. Here's the prehook. The prehook is going to return hook build info. The command hook is going to maybe return a function that maps user hooks and flags to and actually does the operation. I'm not sure. And this is calling out the hooked action with args. And hooked action with args is kind of like similar, but I assume it has args. And the last thing that the hooked action does is it, I guess, returns this lambda, which is going to take an h. No, maybe this is an argument to hooked action with args, verbosity prehook, and then its second argument is this lambda with, I guess, an empty argument. So it is. So let's look at hooked action with args. What does that do? The last line is post hook hooks args flags blah blah blah, and the line before that is command hook hooks args blah blah blah. And we've got some package description stuff. Oh, we're calling do. So maybe this is actually doing stuff. Post hook. So where did we get post hook? That was passed in. Okay. Hooked action with args. I think this might actually be doing things. Because it seems like it's calling post hooks at the end. And let's see, what argument? This is 1, 2, 3, 4. So verbosity is the first one. And then there's 3. 1, 2, 3. And post hook is a thing. I don't know. I'm not sure really whether this is executing stuff. I want to say no, because it seems like it's got more stuff to return. But we are in a monad, and I think that there's funny monad-y stuff that can cause it to like consider more than just the last line when it's returning. I'm not familiar enough with Haskell to know for sure. But so I'll leave it at that. We've got unregistered actions, register actions, bench actions, which is probably benchmark. Dist action. So user hooks are completely ignored since Cabal 3.4. Install action, copy action. Okay. And all of these, eventually, you get hooked actions. Clean action. You know what I'm going to do? I'm going to ask, just for fun. I'm going to see if I'm logged into... Yeah, I think I am. Okay. So I'm going to ask ChatGPT what this function does. Where was it? So what does this Haskell function do? And while it's thinking about that, I will look up the Cabal. Documentation. Okay. It takes several arguments. I know that it takes several arguments. Let's look at the documentation while ChatGPT is thinking through things. All right. So the documentation says hooks allow authors to add specific functionality before and after a command is run, and also to specify additional pre-processes. Yeah, that much is pretty clear. What I'm not certain of is like what actually happens when you create a hook. Like how is it registered? what function call is actually modifying the environment. It's a lot of like terminal green. I think this is just the file. Okay, maybe I think I read this file from the bottom, which I thought would be a way of skipping through a bunch of boilerplate, but maybe I'm missing a comment that explains things very clearly. All right, ChatGPT is telling me it coordinates the three functions, pre-hook, command hook, and post-hook in the context of a build action with the help of provided arguments. Specifically, the pre-hook function is executed with hooks, args, and flags as arguments and returns an IO hooked build info. The resulting hooked build info is then checked for consistency with the current package description using the sanity check hooked build info. Is this true? Yeah, okay. I see. So this does seem like it's executing the pre-build hook with these arguments. All right, yeah, ChatGPT got recommended. Oh, cool. Thanks, Doom Music. So that does seem like we're executing this pre-hook, I guess, and we're getting the PBI, which is package some information. I assume this is what the I is for, and then we're going to get the build config and do some stuff and sanity check the PBI. So ChatGPT seems to be correct. And then we're going to update the package description with the PBI in this stuff. And then it kind of does seem like we're calling command hook and post hook. But let's see what ChatGPT is telling me. Next, the command hook function is executed with hooks, args, package description, LBI, hooks, and flags as arguments, where package description and LBI are the updated package description. Yeah. Finally, the post hook function is executed with hooks, args, flags, package description, and LBI as arguments. Overall, this function is a high-level interface for coordinating several hooks during a build action in a Haskell project. So I guess it does seem like it's executing these things. And, but what is, yeah, so post hook was the last thing we passed in, right? So that consumes 3 arguments. That means that it seems like this function should return an IO local build info. Or maybe it's, no. I mean, there's different ways of thinking about this. So it's essentially curried, right? So it doesn't seem like we're passing in all of the arguments. So whatever we get out of hooked actions with warnings should be something that we can apply to a local build info, essentially, to give us this function, if I understand correctly. But it's not clear how that's happening, because it seems like we're just executing some stuff. I guess, yeah. Okay. I'll ask what it returns. Let's see, 1, 2, 3, 4. An IO action get build config, user hooks, flags, and args. There might be a way that somehow this is kind of IO action get build config. So I guess it's maybe just always called in a certain context that has this stuff. User hooks, flags, and args. But I don't know what it does with those things. Does it use these what was it called? Get build config. An IO action. So ChatGPT is saying get build config is essentially an argument to this function. User hooks, flags, and args. So okay. Oh, these are, you know what? I was just misunderstanding the syntax. Okay. All right. So get build config, hooks, flags, and args are additional inputs to this function. All right. That makes so much more sense. I apologize for that. That's actually pretty simple now that I'm reading the syntax correctly. Okay. Yeah. So these things are passed in and we're going to execute hooks. Okay. Great. Perfect. All right. Okay, so this is there's a lot of stuff about actions and whatnot. I guess you know, the thing that confused me is that initially um, is that when you register an action, it seems to execute it. So maybe they're always curried in practice. Like maybe you call register action hooks, and then later you give it flags and args and stuff. I don't know. Okay. But it didn't seem very registery since it seemed to be like executing the thing you're actually passing in. I'm guessing that maybe the part I'm missing is that it's going to typically be curried, and then to kick off the execution, you have to feed it a little bit more data. Or maybe it's just registered by virtue of the laziness of Haskell. I don't know. Okay, so here we are in distribution/simple/compiler.hs. All right, and the comment says, this should be a much more sophisticated abstraction than it is. Currently, it's just a bit of data about the compiler, like its flavor and name version. The reason it's just data is because currently it has to be in read and show so it can be saved along with the local build info. All right, it doesn't contain much interesting stuff, it says. Okay, so this should be like compiler metadata. We've got package DB. I'm not sure if package DB is part of Cabal. Let's see if we find an import package DB. Oh, this module also defines a package DB type, which is used to refer to package databases. Most compilers only know about a single global package collection, but GHC has a global and per user one. It lets you create arbitrary other package databases. We do not yet fully support this latter feature. So we're going to define package DB. So I'm glad I clicked on this file. All right. We'll check out the comment too. Some compilers have a notion of a database of available packages. While there is just one global DB of packages, other compilers support a per user or an arbitrary DB specified at some location in the file system. This can be used to build isolated environments of packages, for example, to build a collection of related packages without installing them globally. Okay, so package DB is either global or user or a specific package DB. All right. We typically get packages from several databases and stack them together. This type lets us be explicit about that stacking. For example, typical stacks include global package DB. So global package DB is first. User package is second if you only have these two. And I don't know how user package and specific package interact, but if you have these two, then global is always first. Global package DB is invariably at the bottom. Okay, I guess earlier in the list is the bottom, since it contains the RTS runtime system, base, and other special compiler-specific packages. We are not restricted to using just the above combinations. Okay. So a package DB stack is just a list of packages. Return the package that we should register into. This is the package DB at the top of the stack. So we just always register to the top. We get absolute package paths. Optimization. I guess this is kind of like we're going to pass. This is the optimization flag that we'll pass in. Language to flags. I don't know what a language is. Languages and extensions. Unsupported languages. It's going to take a compiler and a list of languages and return, I guess, which ones are unsupported. What is a language? Presumably this is just for Haskell, right? Maybe C. Maybe it means like English versus some other language. I don't see why that would be the case. Just scrolling through, does the compiler support the AR command? Or does the compiler's AR command support response file arguments? So stuff about the R, which I think is the archiver. Does it support profiling? Here's a profiling detail sheet. Okay. I don't know how many compilers there are that this is dealing with, but certainly GHC will be one of them. There's at least one other Haskell compiler whose name I forget that I'm aware of. But I don't know what else is aiming to support. Language to flags. Language extension. Okay, so when it says language, it means language extension, which is these things up here. That's what these are called, I think. Okay. Simple command.hs. I don't know what this is, but I'm expecting some sort of command pattern type thing. Oh no, command line handling. And we're going to ignore that. We've seen a lot of command line handling. Okay. Configure.hs. This is going to deal with the configure phase. All right. It provides the configure action, which is given the package description in configure flags. It then tries to configure the compiler, resolves any conditionals in the package description, resolve the package dependencies. That's, I think, the most interesting to me is how it figures out the dependencies. And it's probably just going to walk a graph, right? Check if the extensions used by the package are supported by the compiler, etc. So let's see if we can quickly find dependencies. I'm not sure if it's going to use the full word dependencies. This looks promising. Okay, configure. The master configure function is gigantic. And all constraints is interesting. All constraints, the set of all dependencies we have used only to configure finalized package. These constraints are to be applied to all components of a package. It is not an error if all constraints contains more constraints than is necessary for a component. Another component might need it. So all constraints, let's see. We've got, what am I looking at? We've got two of these typey things. This is a parenthesis. Where does it terminate? Maybe here? Is it like a tuple? Where all constraints is, I guess, a variable of type package version constraint. Required dep maps is a variable of type, essentially a hash map from package name to component name and installed package info. And we're either going to die, I guess, or return combined constraints. We're calling configure on the constraints, configure dependencies, and the installed package set. Okay. So here's the package description. The resolved package description that does not contain any conditionals because we have an assignment for every flag, either picking them ourselves or using a simple naive algorithm. Either picking them ourselves using a simple naive algorithm or having them be passed to us by configuration flags. All right. We have a list of installed package info recording the selected dependencies. Cool. This looks like a big thing. Compute installation directory templates based on our user configuration. All right, so installers, language list, langs. This is kind of like more, just like, it seems like we're preparing to do serious work, but I'm not sure we're doing it yet, I guess. Check foreign function library build requirements. Just getting all the things that are required for the build. Configure certain external build tools. Let's see what some of the external build tools are. Enabled build infos. First, we collect any tool dep that we know is external. This is in practice the build-tools entries on the whitelist and the build-tool depends that aren't from the current package. Okay. So I guess those are in the Cabal file that aren't from the current package. Okay, so the build tools I think are listed in the Cabal file. And then their dependencies. The dependencies of things that you depend on. So I guess like transitive dependencies maybe of the build tools, I think. program DB, we're going to configure all known programs. Okay, configure required programs. Compute internal component graph. All right, here's what I was looking for. I think the general idea is that we take a look at all the source level components, which may build depends on each other, and form a graph. From there, we build a component local build info for each of the components, which lets us actually build each component. All right, so we're going to create a graph as expected, and then from the graph, we're going to build, that's where we get the component local build info, is after we build the graph, we do something with the graph, or at least maybe we just call some function on every node. I don't know if we need the whole graph structure to do that, but and that lets us actually build each component. And then presumably, based on the way they've written this, they will call GHC on each component in turn, and then pass GHC a reference maybe to the compiled dependencies that they built in the previous step. We'll see. So run log progress, verbosity, configure component build, local build infos. What are we passing in? We're passing in a list. We've got build components, which is a list of component local build infos. Those are essentially the nodes of the graph. And a package depends index, which is the installed package index. Don't know what it means by index, so maybe like a map or a hash map. And yeah. And we're going to call configure component local build infos with some verbosity modifier, whether use external internal depths. I don't know what that is. Maybe that's a Boolean to configure some stuff. Package description, external package depths, which I think is different from internal package depths. Right. And configure flags, installed package set, and comp. Maybe comp is compiler. And then we're going to decide if we're going to compile with split sections. Split sections is a bool. And it's going to check the config split sections flag. All right, GHC.js, is that for compiling to JavaScript or something? And we're going to check the compiler version, and that, I guess the compiler version is going to determine whether we are splitting, whatever the splitting thing is. Decide whether to compile with split objects. Compilers support GHCI libs, so I guess GHCI stuff. GHCI lib by default with GHCI lib. Shared libs by default. So this is whether we want to build shared libs, I guess, at least by default. dyne.exe, I'm guessing, is dynamic executable with whether we want a static library. All dependent libraries rolled into a huge .a archive, etc. Set prof LBI, set coverage LBI. We can turn off library and executable stripping when debug info is set. Okay, something about reloc, maybe relocatable code. And build components map. And we're going to call fold left prime. I don't know what the prime does. With this lambda, we're going to apply this lambda to map.empty build components. I'm not sure. So essentially we're applying this lambda to each of the build components using fold, I think. And the thing that we're applying is going to take a CLBI, so some identifier for a component thingamajig, and insert into a map, I guess. We've got coverage stuff and profiling stuff. And this is defining like a local build info node. And the component graph is graph that from distinct list build components. These build components map is here. And we're going to set the component name map to be equal to build components map. So whatever we did here by folding, which is we created like a essentially a dictionary of component stuff. Now we are putting it into this local build info stuff. And okay. And just configuring stuff like, is it relocatable, exe coverage, whether to strip stuff, whether it's fully static. So this is a bundle of config that is presumably going to be passed to the compiler. Nice, some package root stuff. Package root. Allowing package root to be passed as -- prefix to Cabal configure is only a hidden option. It allows packages to be relocatable with their package database. Very cool. Some verbosity stuff, some prefix stuff. Dir info, executables, libraries, dynamic libraries. So this is, I guess, where the stuff is going to go. And maybe these are human readable strings here just for output in the second column. And we're going to call sequence, which is maybe, I've used sequence before. I think either it unmonadifies some stuff or it executes in parallel. I forget what it does. But we're going to call it on this list. It's got 2 square brackets, which I think in Haskell is only a list, and it's got this or sign. And I think square brackets with an or sign is essentially set builder notation. So I'm guessing that this is to be read as like a set, set theory type notation. So report program verbosity prog configured prog such that the tuple prog configured prog is in maybe the known programs from the program DB. So we're gonna, I guess, filter only the known programs and do this stuff with it. Okay. And call sequence. Let's look at what sequence does. And then we're going to return LBI. Okay, sequence underscore has the same behavior as sequence, but does not return a list of results. So it's like a side effecty sequence with no underscore. Let's find out what sequence with no underscore is. The sec type represents a finite sequence of values of type A. Sequences generally behave much like lists. That's the type data sequence. I think I want the function. They might be different. Sequence. Run a pipe repeatedly. Evaluate each monadic action in the structure. Can I see more? In the structure from left to right and collect the results. Okay. Here's an example. Sequence. Oh, whoa now. I guess I wasn't supposed to click there to highlight it. Okay, that works. No, it doesn't work. All right, so calling sequence and this $sign basically means apply this to this whole thing, kind of grouped. Imagine this is the right-hand side is grouped by parentheses. We're going to call it on write 1, 2, 3, 4. And that's going to return, that's going to call write on everything in the list. Okay. So it's like map. It's map-like, but maybe in a monadic context. Okay. So it's going to essentially iterate all of these things over all of these things, and it's going to return LBI, which I assume info. So if we look at the signature, we should see that it returns something info-y. Yeah, it's going to return IO of local build info. Cool. All right, so that's configure. That's going to build up the map. I'm not sure where it actually does something like topological sort, but that might be wrapped into either the fold or the sequence call is what I'm going to guess, or whatever function they pass into fold or sequence. Just out of curiosity, let's see if we can find the word sort or topological. Here we go. Package index, that topological order. Okay. I was not expecting that to actually have any hits. So, blah, blah, blah. Let's see if we can find this. So where was package index? I think it was, it's under simple. Okay. So I think I can do this. Whoops, don't do that. Package index. Let's see if we can find the topological order thing. Okay, so a topological order is going to take a package installed A, a package index A, and return a list of A. The index is going to be a map to package ID graph top sort graph. Okay, so we're just calling out the graph topological sort, which is totally reasonable. So is graph something we're importing? I want uppercase graph, and I want to match the case, I think. Oh no, can I go to the beginning? Okay, so we're importing dependency graph. Oh no, we're exporting. Okay, we're importing data.graph as graph. So data.graph, Haskell, topological order, I think we called it. Just out of curiosity, just verify that this is a thing. Top sort. Okay, a topological sort of a graph. The order is partially specified. Okay, cool. So the topological sorting is done in library, and that's pretty expected. Okay, so here's build target. I think we might have a sense of what build target is up to now that we've seen it used. We can get the file components. You can read user build targets. Okay. Build target approximation is going to take a Cabal parsing M and then build target. Read 1, 2, or 3 tokens where the last could be HS string. So this is reading, this is like tokenizing some stuff. Resolve build targets. Given a bunch of user specified targets, try to resolve what it is they refer to. Okay. Resolve build target, find match, unambiguous, ambiguous. I don't know. Match errors, package ID. Maybe, I guess it's comparing it to a list of known packages. And I'm not sure how there can be an ambiguity. And we're so it's nearly 2 hours. So I don't want to make this last forever. But I'm a bit curious. I'm going to resist the urge to dig into down there. HPC, I'm just curious what this means for the HPC, library interface to the HPC program. Invoke HPC with the given parameters. Prior to HPC, HPC did not handle multiple. What is HPC? There seems to be a program in the Haskell Haskell program coverage, high fidelity code coverage. Okay, so support for code coverage, cool. Types, I guess I'm not going to really look at, but we've got some types like program search path, simple program, configured program, suppress override args. DB, yeah, that's good. This provides a program DB type which holds configured and not yet configured programs. It is the parameter to lots of actions elsewhere in Cabal that need to look up and run programs. I guess I'm curious whether this has like a table of like known programs that are just built into the code. But no, it seems to be for building program objects as part of the compilation project. Okay. All right, cool. Well, that's ChatGPT, so I guess I'll leave that open. And then I'll take a quick look at the solver benchmarks. I just want to see what it's considering the solver. I guess there's a dependency solver, and I must have missed it because I didn't see anything that looked like it was like running a general purpose solver. It's going to just call package benchmark main. Oh, yeah, I think I want this file here. Was it importing? Oh, this is exports. System type, system process distribution, package name, package. So where's solve? What's it? I'm not sure. So it's got some library stuff. I'm guessing by solver, it might be just referring to the code we looked at before that's like looking at the dependencies and maybe also the topological sort stuff and figuring out like which version goes where. Okay, so here's the Cabal syntax package. I'll look at this very quickly, I think. We've got this extension. Maybe that's just the definition of the Haskell extension. Here's distribution. Again, we've got compat field grammar. I guess that's field, or maybe like what you would think of as members or fields, I guess, of a record. Parsec is a parser thing. SPDX is the license description scheme thing. And we've got types and utils. Some of these seem to be like, now that I've looked at a few Haskell repositories, some of these folders like compat and types and utils seem to be relatively standard. And we've got grammar and system and text and pretty and package and backpack again. So maybe we'll look at one of them. Let's look at parsec. And then we'll call it a day. So we're going to use bang patterns, flexible contexts, GADTs, which generalized algebraic data types, I think, rank n types, and scoped variables. So we've got some fancier types than in a normal Haskell file. Not totally surprising if we're parsing stuff. And I think that parsec is separate, right? We're going to use import qualified text.parsec. Okay, so a class for parsing with parsec, mainly used for .cabal files. We've got class parsec where some stuff. Okay, parsing class, which can report Cabal parsing warnings. So we can report warnings. Here's a lexemes thing. Lifting. I'm not sure exactly what it's lifting, but I guess maybe from a monad. We have a functor parsec parser. And we're defining, I guess, fmap and whatever maybe this thing is. An applicative parser. Okay. Simple parsec. Explicit either parsec, which will take a Cabal spec version and a parsec parser and give a string. Return either a string or an A. Maybe it's used for errors. Parsec token, which will take a Cabal parsing M and return an M string. And this stuff is unreadable to me because I don't know what this. This is a lambda. This is and, of course. This is not equal. Don't know what the angle brackets with the question mark is. I think that's some sort of parser combinating parser. I don't know if you would call it a combinator. And I also don't know what this one is. And this is maybe the monadic bind, or maybe bind goes the other way. I forget, whatever this thing is called. I think that's monad related. Okay. And then this would all, I think, be super fascinating to go through carefully with an eye to seeing how a real parser in the real world is being written. This is part of Cabal. So this is run every time you build stuff in Haskell that uses Cabal. So this is presumably all the bugs have been ironed out, or many of the bugs have been ironed out compared to like looking at a tutorial. There must be a ton of parsec tutorials out there. And I know for sure there are a ton of Haskell parsing tutorials, but this would be maybe an additional place to look if we wanted to learn more about a Haskell parsing library that's used in the wild. But since we're at almost exactly 2 hours, I'm not going to go any deeper right now. So I'll leave it there. So that is Cabal. I'm not sure if I have anything super interesting to say as a summary, other than I feel like every time I look at a Haskell code base, um, things seem very clean. Uh, Putting aside the kind of confusing like symbols that people can define as like part of like defining new algebraic symbols, um, it's often pretty easy to see what's going on. It seems like Haskell developers have kind of like a clean and tidy approach to things. It can be nice to read. This was a little bit. This code base maybe was a little bit. It took me a little longer to find my bearings compared to some of the other code bases I've looked at. Um, but I don't know. There's something very appealing, I guess, about Haskell, and the I guess I didn't appreciate that that Cabal had this thing that they're calling simple, which is really where most of the complexity lies. Um, and yeah, so that's Cabal. Tomorrow I'm taking a look at the source code for the Brave browser, which is they have the Brave token. I'm not sure whether you would consider it a part of the cryptocurrency space or not these days. I think back in the day that was part of their thing. It may still be, but the Brave browser is built on the Chromium code base, and I had a viewer request that I look a little bit more at the web browsers. The very first videos I did were about web browsers, and so it's natural to ask like things like, well, why are some, if things are based on Chromium, why are some slower or faster than others, and how does the UI work? So those were some of the sort of questions I was asked, and so I'm going to look at the Brave browser kind of as certainly one of the open source Chromium based browsers that comes to mind. That's not something like Chrome and Microsoft Edge. Those are those customizations are closed source, but at least some of the Brave stuff is open source, and I think maybe all of it is. So that's what we're doing tomorrow, and then next week I've got a schedule up, and so that's all. Thank you. Thanks for watching. Bye.